Hello, and welcome to my progression post of not progressing at all. Okay, that was kind of hard to say. Progression. Progression. Recently I was kind of listening to my own voice through my own videos, and I kind of noticed that I have an accent or something. I don't even know what kind of accent it is. Not like a Japanese accent or something. Maybe it is. I don't know. But nevertheless, I figured that it's kind of hard to understand me, so...
What's up guys, it's yo homie Google Translate Chan here to speak for Kato instead.
Okay, just kidding. You know, interesting, whatever I just put into Google Translate apparently translates to "doshita in Japanese, which roughly translates to "what's wrong?" Okay, enough of random talk, let me get back on to topic. So after I was done making the 2D Geometry Dash looking whatever scuffed game I just made, I wanted to go back to 3D and make a third-person game instead. Well, first things first. Probably the most important thing to a 3D video game, actually any video game, is the player movement. So that's what I tried implementing first. And as you can see here, it works perfectly. Like, have you seen a more sophisticated movement than this in a video game? It's absolutely amazing. There's nothing wrong with this. What can there be that's wrong? And now that we know this works perfectly, we can go on to our next step. Gravity. So adding gravity should be pretty simple. It's just coding the computer so that it checks whether the player is touching the ground or not, and give it a true or false statement based off of that. So for example, it's true if the player is touching the ground, and false if the player is not touching the ground. Once that's done, you basically just have to constantly add a downward velocity every second to the player when the player is not touching the ground. And that constant velocity can basically be anything, but let's say I wanted to make my game realistic and I wanted to add a constant velocity related to that of Earth's gravity, which is 9.81 meters per second squared. Then all you will have to do is multiply that by time.delta time, which is just code that basically means gravity every second. In short, I'm just adding a constant velocity of 9.81 every second. Once that's down and the player is touching the ground now, you basically just have to reset the velocity back to 0 or something like that. Now that all the boring physics stuff is down, let's see how my code works in practice. And it's perfect. Absolutely perfect. You know, honestly, I tried fixing a lot of these as I went, but as I fixed them, there's just more and more bugs. I mean features. Yup, no problem at all. Yup, it's a feature, not a bug. Nope, no problem. Yup, it's all good. Yeah, had to fix all of that. Well, after all that was done, all I had left to do was just add a jump. So in order to add a jump, there's actually multiple ways to do this actually, but the one that I used or figured was to just add an instantaneous velocity, or like an initial velocity to the player object in the upward direction, and hopefully gravity would slow it down and for it to like jump a distance. And in order to calculate that, it's just simple physics kinematics. High school physics time! Oh man. Don't worry, we don't need all of this. We only need the kinematics part, and specifically this equation. Oh my god. I'll start off by rewriting the equation. Vf stands for velocity final, Vi stands for velocity initial, A stands for acceleration, and D stands for distance. Imagine a person on the ground trying to jump a vertical distance D in this case, in the positive Y direction. Okay, so and obviously in this case there will be gravity pushing him down in the opposite direction. And remember, gravity is an acceleration. And if you try to imagine the person trying to jump a random distance, and by the way my vector D is not to scale here, at the top of the person's jump, his velocity final is 0, and velocity initial is what we're trying to find. So then we can simply denote here that velocity final goes to 0. Next up, I'm just going to quickly rearrange the equation, and then you'll come to an equation of velocity initial equaling to the square root of -2 times acceleration times distance. Then we can quickly remind ourselves that acceleration is equal to the gravity, which is also 9.81. But remember that the gravity is a downward force, so gravity in this case would be negative.
Okay, cool, I don't care.
Next, as a reminder, our distance we're trying to travel is in the positive direction. And let's just say we're trying to jump 1 meters for now. And finally, we can come to our concluding equation of saying that our initial velocity, or the necessary velocity to jump a distance of 1 meters, is just the square root of 2 times 9.81 times 1. Finally, Jesus Christ, man. Great, so now that we got that problem solved, I can just implement this into my code and there should not be any problems, right? Press space to jump, and nope. Thanks for watching, I guess. I don't even know what this video is about, honestly.